All right, well, good morning. So, today, what are we gonna do? Well, got our drive shafts back from John's Custom Drive Shafts down south. Got the new big 1410 rear shaft. I'm gonna bolt it up and start checking it for clearances, droop out the suspension, and hopefully everything that I have mocked up is gonna work. Keep U-joint angles happy throughout the entire suspension travel, bump and droop. If not, we'll make the necessary adjustments. These shocks in the back are 18s, which is overkill probably for this build. Probably only needed 16s, but I got a really good deal on them. And with that being said, I want to take advantage of as much of that 18 inches of shock that I can. So anyway, yeah, on to the back end. We've been working on the front end for quite a while, and we can get to the back end and start really making plans for the upper shock mounts, and it all sort of stems around the drive shafts. Stems around a lot of things, but drive shafts being a big thing. So all right, well, we got the rear drive shaft in. A little bit of a process because I had to install the third member. The mock-up third member didn't work with the U-straps I had for the U-joint. We're at full droop right here, and I've got plenty of clearance in the drive shaft. She spins fine. I'm really happy I went with the 1410 series U-joints. It gives me a little more angle. So we're good there. I'm gonna drop it down to full bump and check and see how she does at full bump. And then I still have a little bit of angle left. I might try to move the lower shock mount up one position, which will give me even more travel in the rear. Right now I'm at about 21 inches of vertical travel, which is plenty. I probably should just settle with that, but I just want to see what it'll do. So here we go. All right, here we are at full droop. I tested all three positions on the trailing arm, or the mock-up trailing arms. The rear position, I had to remeasure everything. My bump numbers changed because, or my full bump level changed because, believe it or not, at full bump, because of the high pinion, the yoke on the U-joint hits right here on this cross tube. So I can't go as high as I thought I could as far as the bump is concerned, but that's okay. That's why we're doing all this. Obviously didn't have operating drive shaft to test with before, so that's why I was waiting to get that thing. So here's what the numbers say. If I have the shocks in this rearmost position, it yields the least amount of travel. It's about 19 7/8 of vertical wheel travel in the back. And everything's happy. The drive shaft's happy. It spins fine. There's no binding. If I go to the middle position, which is where it's at now, it gets me a little bit more travel. It gets me to about 21 1/4. And drive shaft is happy. Everything spins. There's no problem. If I go to the front position, that's when the drive shaft starts to bind. I would have to strap it up a little shy of full droop, which I'm gonna have to strap it anyway with the shocks. I could still use it, but then the shock starts to get close to this. And I'm worried about when I articulate, it's going to bring the spring into the frame rail. So I think we're gonna settle with this middle position, and we're gonna fabricate off of that setup. Now I know what my link lengths need to be. I know how to design my trailing arms. My upper link mounts on the axle, I can get those fully boxed in and gusseted and welded out. And yeah, so I'm really happy with this. I'm happy with the way this is turning out. Everything that I did before, my homework paid off. My drive shaft angles are happy. It's a win. It's a win today for sure. So next thing I need to probably do is just that. Roll that rear axle out of here. Get things more permanent on this upper link mount setup. Gusset and box in the lower link mounts. I have a backbone truss that I need to put on here. And I also have a diff skid that will go mount underneath the third member that I need to mock up and start welding up too. So yeah, a little bit of progress. This stuff takes forever to do, up and down with the lift. I'm so happy I have the lift. I'm very grateful for that. But that gives me a better idea of everything. Kind of tells me where things are at. And I can start welding in this stuff. The link mounts over here on the frame side or chassis side, the uppers and lowers, and start tearing this thing back down again so I can start welding out a lot of this stuff. All right, well, good morning. Had a good night's sleep last night. I think yesterday I didn't really get a whole lot done except for get the drive shaft mounted up and the third member in place and start checking everything for clearances and droop numbers. And I think what I'm going to do today is focus on getting these upper shock mounts sort of designed and mocked up, put in place. I know I already have mock-up upper shock mounts, but these were just for testing and testing position, testing droop, testing clearances, numbers, whatever you want to call it. But where the shocks are right now is approximately where I want the upper mount to be. I'm going to need to turn them around so that the hose, rather than coming inboard, is coming outboard. And I may need to add a fitting so that the hose doesn't come out here past the cage plane. I don't want the hose to be rubbed off on a rock or in contact with a rock. And then these Mondo remote reservoirs with the cooler fins, I would like to have mounted on the inside of this tube here, away from harm, out of harm's way, I guess. That means I'm going to have to, I ordered mounts for these fin coolers. They're special mounts, that are clamp mounts that go on these. I ordered those. But there's one thing that I thought of last night. Now that I have the third member in place, when I bump out the rear axle, when I go as high as I can, I'll put you down here. Maybe this is easier to see. The U-joint or the yoke hits this bottom tube. And obviously I never had encountered that before because I didn't have a drive shaft, a rear drive shaft. So when it hits that tube, there's still shock shaft showing. So that means to me, I can move the upper mount down some more to establish full bump and no shock showing. And that will net me a little bit more down travel and droop, which I can do and the numbers work out fine before the drive shaft binds. So in other words, if I move the upper shock mount down just a little bit, where it bolts up, move that position down maybe an inch, that'll net me another inch of droop down here. And I can afford to do that because the drive shaft doesn't bind for at least another 1.5 inches. So I'm going to take advantage of all that travel that I can, and then also keep in mind that the rear axle is going to be strapped before I reach full droop on the shock. That's just a safety measure. That's insurance. So use every little bit that I can. That's what I designed it for. And I've got these big old Mondo 18-inch shocks, so I might as well use as much travel as I can. The only other question is because this thing has so much articulation, when the tire swings down on one side and all the way up on the other side, if you can imagine it tilting in, the tire never comes in contact with the shock, but the shock gets awful close to the frame rail on both sides. So that's the only other concern. I don't think it's going to, that's not like a constant situation. That's a very rare situation, but that would be the only other minor concern. Because I don't have springs yet, I can't really test that. All I can do is use the shock slider, because the outside diameter of the shock slider is pretty much represents the outside diameter of the springs. So anyway, I think that's what we're gonna do. Yesterday I didn't get very much time last video because there really wasn't anything to really show on video. And plus I was having trouble with the GoPro battery. So anyway, that's what we're gonna do. I'm gonna bump this out. I'll get you back in here and show you how much shock shaft is still showing. And then that'll give us a number of how much higher we can go with that upper shock mount, or how much lower, I mean. And then we'll net a little bit more droop out of that middle position on the trailing arm. All right, here we go. All right, so I got the axle raised up at full bump, and you can see the drive shaft yoke is hitting that frame cross member there, and there's still, and it's not as much as I thought, but there's still about, I don't know, we'll call that 5/8 or so of shaft showing before that big rubber bounce bump stopper. So yeah, I mean, I can move that shock shaft down. I'll move that shock mount down by 1/2 inch, maybe to 5/8, and call that good. And then also keep in mind, there's also going to be massive hydraulic bump stops mounted here on the frame rail, straight over the axle, and that's going to stop. That's going to slow things down before it gets to actual bump anyway. So all these things you just got to be kind of prepared for before you do the final and make the shock mount. So that's what I'm going to do now. Is I'll start drawing this up. I got to make clearance for this hose coming out this way. This tube here, we'll see how I configure it, but I'm thinking this tube slides up here more, because it doesn't need to be way back here, because obviously you don't need these holes. So, and then the upper mount is going to be boxed in, maybe a combination of tubing. We'll see what I come up with, tubing and plate. But then I want it to tie into the back of this as well, to the back of the cage here as well, because there's a lot of forces coming up. And bridging it would probably be just fine, but I also want to tie it into this tube for insurance and rigidity. So yeah, that's what we'll do. And the other thing I was doing yesterday that I didn't get on camera was finishing up these lacing tubes. This tube's going to go something like this. Needs quite a bit more adjustment, kind of gappy still, but that tube will go like that. And then if I leave this cross tube in here, in this position. Then there'll be another tube that goes up to the bottom of that from this joint here, or from this node. And I'm contemplating whether or not I should make this tube removable, because otherwise, if I do the big 32-gallon fuel cell, if this tube is not removable, the only other way to remove that fuel cell is to slide it out the side here, which means taking the shock off, taking the tire off. So, yeah. Anyway, all right, here we go. All right, so I got the mock-up shock mount taken out of the way, or taken out. I need to grind these welds back down. I cut this tube out, and unfortunately now, if I slide it up here where I think it needs to be, it's loose in here. But that's okay, because this cross tube back here is only tacked in, and I can move that this way and possibly reuse these tubes. In fact, if this was out this way a little bit more, that would make clearancing for taking the fuel cell in and out a lot easier. So now what I got to do is take this shock mount. I got a couple reference lines on here. I'll go over the computer. This line right here represents this plane on the back of the cage. You can see over there where the mock-up shock mount sticks out past the plane of the cage, right there. And I don't want that. I want it behind this plane of the cage, because I'll probably end up putting some sort of a back firewall on here. If not a solid fire, well, it won't be a solid fire. It'll be like a screen of some sort so airflow can get through. But anyway, so zoom back out here. This right here represents that sort of that plane. This right here represents what would be the back of the shock mount that comes down to this tube. Then I know I can move this down by about 5/8 of an inch, and then somehow tie it in to this up here. And I still don't know if I want to do a combination of just plate structure or tube and plate. Plate would make it simple because everything's pretty much geometric. Tying into tube, and tube might not be necessary. I do have some 1.25 inch tube. As a matter of fact, I have a bender. I can bend 1.25 inch. Need to think about that. We'll see. Anyway, so over to the computer. I'll probably be over there for a while. Then I'll cut out a new designed mock-up out of 16 gauge, bring it over here and test fit it. All right, well, this is what we got. I think that'll work. This is kind of rough. I made sure the edges were squared off because I'm thinking making them squared off is going to be easier to plate everything in, but now that I'm thinking about it, I don't want them squared off. But anyway, the geometry in here is correct. I think that's going to work just right. I want to radius these corners, and then I'll cut another one, tack it in here, cycle the suspension. The front of it is not sticking out past this plane, so that's good. This tube is definitely going to have to be moved over this way because this is super loose in here, which is fine. That's why we only tacked everything in. And then if you can picture from here, this outside plate having a bridge or a, I don't know, maybe an A-frame that goes up to here, up to this tube here. I might have to put another tube across here to give it a good place to land. I'm not quite sure about that just yet. But I think the next step will be cutting this tube, the tack's loose on this tube, moving this over and cutting another one of these, getting them in there nice and solid. I was really happy with the way this corner worked out. I probably don't need that much of a relief in here now. I can probably take this and round it out. And then I put that relief in there for the hose. The hose is going to end up coming out this direction. And I'll talk to my shock guy. I think I can put another 90 on here. It would be really helpful if this hose came out and then 90'd and went back that way. Hopefully that doesn't mess things up for flow dynamics or whatever on the hydraulics and the shock. But that would be really handy. Then that way I don't have to worry about this hose, because it's not super flexy, but this fitting is very close to the outside of here. But if I can do that, then I can have that 90 back, and then it'll make it super easy to mount that reservoir on the inside of this tube. Yeah, so I think next step would be cut another one of these plates. I might mess around with the radius on here and radius that out, and then I'll break those tacks, move that over, tack this in, then cycle the suspension. All right, here we go. Okay, this is where I'm at. So I've got mock-up shock towers in here, or shock mounts in here. And I got this tube moved over, this tube moved up. These tubes are tacked in. The way I have this hose routed, I got to thinking about it, because I want to put this Mondo reservoir on the inside of this tube here. I mean, this hose is not super flexible at all. I mean, it's flexible, but it's not the best. Trying to do this with one hand, but anyway, if I got that in there, I got to thinking it sure would be easier if this hose is coming out the other side of the shock. So in other words, I mean, it's not going to be easier, but it's going to maybe make it easier to mount the reservoir up here closer in this way if this hose is coming off of here, which would mean I would just move the shock that's currently mounted on the driver's side over here. So, but in doing that, I have to cut a big relief in here for that hose to come out. So I designed another outer shock mount which I have right here. I didn't clean it up, but anyway, this relief in here would be for that hose. And I just copied that off of the mock-up shock mounts, where I basically relieve that in there with a die grinder. And we'll see if that's enough. I don't know if it will be. And I'm thinking that will make it easier for hose routing. These hoses are huge. Anyway, that's where I'm at right now. I'm going to take that shock off of that side, bring it over here, mount this up, see if this is a better idea or if it's better routing wise. If that is, then I think I'm going to go ahead and start designing the final shock mount that ties up into the cage up here. All right, here we go. All right, I can already tell you, I think that might be a better plan. Having this hose come out here rather than back here. The only thing that it's going to interfere with now that I can think of is a gusset that's going from this tube down to this tube. But if I'm able to put a 90-degree fitting on here, then I think we're going to be golden, because I can rotate that 90 upward, and then I can make this reservoir mount in there. That's kind of what I'm thinking. So I think we're going to call that good as far as that's concerned. I do want to go ahead and droop this thing out just to make sure that this clearance that I cut into this, you can see my fingers behind it, is enough. So we'll droop it out. and we'll check in again. All right, well, I haven't pulled the tire off the ground, but the drive line is bound. It's definitely flexed out way more than I had it before. So the main concern though was to check this fitting right here and make sure there's plenty of clearance around it, and that appears to be no problem. So I can drop this thing back down and we'll see. It's hard to believe that made that much of a difference by just dropping this bolt hole or this mount location down 5/8, but I think next what I need to do is bump it out and see what it looks like. All right, so we got this thing at full bump. No daylight in there that I can tell. Shock mount, so there's no shaft showing. So I don't know how the ratios work, but I got a lot more droop just by moving this bolt down 5/8 of an inch. Maybe I only needed to move it down a 1/2 inch, but exponentially made a difference over here on this end. So that's fine. I think I work on getting these upper shock mounts finalized and start working on the real thing, designing it, tying it into here, and then I can play with these again, which I've already done, but maybe I only need to go back to this one. Or it doesn't really, oh, I guess it doesn't matter. Just thinking out loud, I'm gonna have to put limit straps on this anyway, so I could strap it right before the drive line binds. I don't have to worry about these drooping out all the way. And then of course I'm gonna have my bump stops over here, so that's all good.